Hello friends, in the second episode of MakerHacker, we are going to build an IoT plant watering system using Particle Photon development board and a servo motor. We also need few items that you can find in your home scattered across, such as a water bottle, some connecting pipes, etc. And we can actually build this IoT project from scratch. So as you see, I have built one such system and installed in my balcony, and it worked perfectly. We'll also do a very simple programming so that we can turn on or off the valve using mobile, or simply make a schedule to plant the water for the desirable time we want. So the valves turn on for a specific amount of time and then turns off automatically after the period is over. So what are we waiting for? Let's start.
Okay, so let's see how the connections are made right now. So you can see that I have this power supply, which basically takes a 5-volt input and then converts that to 5-volt and 3.3 volt. Actually, you essentially don't need it if you need only 5-volt. As in our case, we are only going to use a 5-volt, so we don't essentially use this. But I always use a power supply for better, voltage stabilized voltage. So it's better to have this all the time. And on a breadboard, as you can see that this is the 5-volt line. This is positive and negative. And I've connected this to the particle photons, V in and the ground, as well as we need to provide the 5-volt supply to a servo motor also. So that's the reason on a servo motor you can see that these connections. Okay, so this is the ground, the first pin, then the positive voltage supply, and then we have a control signal. The control signal is basically the angle to which the servo motor will basically rotate. So the power supply is connected to 5-volt again over here, and the control signal pin, this is connected to the D0 pin of the particle photon, as can be seen over here. So connections are pretty easy, and the next thing is basically to use the cloud for programming. So let's see that.
Code is made up of. You can see that we have declared some functions, right? Servo. Now servo is essentially the one which is going to control our motor. So defining this is very important. Then we have some counter for schedule, some boolean parameter also like schedule. So we need to identify that. In a setup, we need to just first of all create a servo attach. So as you can see that in the hardware we attach a servo motor to D0 port. So it is essential to declare that in a setup, and then we are going to subscribe to a function called switch, because as you can see that in a mobile app, when we enter attribute or command parameter for switch as on, off, or schedule, it is going to receive and then accordingly act. In a loop, then we are going to have essentially the schedule function where we have a counter of defined 10 seconds. It is written over here. We can actually change that to any desirable value, and a time period delay is given as 1000 milliseconds, which is 1 second. So which means that 10,000 milliseconds is going to add a 10 seconds of a delay for a schedule. And this is the function, particle function, which is defined is over here, declare over here. So as you can see that when we receive a command on, the servo is going to write to 170. So it is going to rotate 170 degree, and then when we say off, then it is going to bring it back to the original position. And when we say schedule, it is going to basically set the parameter schedule as true, and then it is going to write a servo motor to 170 degree to turn it on, and then it goes and hand over to the loop, and the loop will handle it for a 10 seconds time delay, and then will turn off the servo motor after the 10 cycles are elapsed, and then it is going to set the counter to 0 and schedule parameter as false. So the code is pretty simple. You can find it in the link given in the video description, and also in our GitHub channel as also. So let's see now how to flash this. So flashing it is very easy. First of all, we need to click this verify button and see that our code is compilable, and you can see the status here saying that code is verified, right? And then we're going to press this button called flash, which will basically flash our particle photon through the cloud, right? So you can see that the status is over here. Now it is giving flash unsuccessful because our board is not connected. Once we connect our board and power it on, you would see that the flash would be successful. So let's try it again by pressing the flash button. Now we have turned our particle photon. Now press the flash button. Let's wait for some time. And if the flashing is successful, you can get this message. So now the flashing is successful. Our code is on the particle photon board. And if you want to understand how do we use this particle photon connect to the cloud, there are tutorials available on the particle photon website also that you can see.
Okay friends, so now the circuit is ready, built, and now good for testing. So I have a particle photon companion app on my mobile phone, and where I'm going to the particular particle photon, which is Centronics 1 over here, and I'm going to navigate to functions. Under the functions, I have a function which is published, which is switch, as we have seen in the code, and I just need to pass some arguments here. Now, what are the arguments that are supported in my code? Which are on, off, and schedule. So when I send the on as an argument, it is going to publish to the cloud, and the particle photon is going to receive it, and the servo motor is then accordingly turned to anti-clockwise. When I publish an event argument as off, it is going to turn clockwise. And if I publish an argument schedule, then what's going to happen is particle photon is going to receive this command, and then it is going to first turn on, which means it is going to rotate anti-clockwise, and after 10 seconds it is going to turn off, which means it is going to turn clockwise. So let's see. So I'm going to now first publish an event called on. I send the on. As you can see that it is anti-clockwise, and I'm going to publish an argument called off. It turns on, and now I'm going to type the argument as schedule and send it, and you can see that it has turned on now. And let's wait 10 seconds and to see what happens next. And in exactly 10 seconds, you see that it has turned off. So the primary function of the app looks perfectly fine.
I hope you enjoy the video. If you like it, just share and subscribe to our channel for more exciting videos like this.